Okay, moving forward. 21. Testing a claim about P. P is a population proportion. So we're going to have a ho, which is going to involve some P, and then a ha, which is going to involve P. We're also going to be using a test statistic, which is this formula. And this formula just standardizes the sample statistic that you found. And this test statistic is going to help us find a p-value, which I'll show you on the problem coming up. And there's a one prop z test on the calculator to make things go a little bit smoother. So 22. When she was just 9 years of age, Emily did a science fair experiment in which she tested professional touch therapists. I don't know how one becomes a professional touch therapist. To see if they could sense her energy field, she flipped a coin to select either her right hand or her left hand. Then she asked the therapist to identify the selected hand by placing their hand under her hand without seeing it or touching it. Among the 280 trials, the therapists were correct 123. Well, they're not off to a great start, I'll tell you that. 44%, it's weak. And it was a real study, you could Google it. So let's use I want to change this to 0.01 significance level. Use a p-value method. I should have had another sentence in here, so let's write this down. Use that significance level to test the claim that therapists use a method equivalent to random guessing. Use a method equivalent to random guessing. So based on that sentence, my ho is going to be this. That would be random guessing. So you either are randomly guessing or you are not randomly guessing. All right? It didn't really tell us if they're under correctly getting the answer over, if they're getting it under or over. All right, now the test stat. Z is p hat minus pq over n. So p hat is what we got from the sample. That's 0.44 minus p is this p. 0.50. These are the same p's, so that's 0.50 times 0.50 over n, which is 280. And from here, I'm going to just use my calculator. So if you go stat, test, one prop C test, enter. So there's 0.5, that's the ho. 123 over 280, that's the x over the n. These numbers have to be whole numbers too, you can't put decimals. And then you have to copy the symbol that the ha gives you. So not equal to, less than, greater than. So we're going to choose that, then we're going to calculate. That's the test stat. That's the p-value. That's the p-hat, which is up here, and that's the n. So according to the calculator, and you could do this by hand if you want, but negative 2.03. So going out and doing this experiment, Emily's results were 2.03 standard deviations to the left of where they should be if they were just randomly guessing. So now to find the p-value, put that number here. These are z-scores, so that's the middle. And this is a two-tail test. This is a two-tail test, which means I have to double my p-value. So what you do is you go at least as extreme as wherever your value is. So if my value is -2, more extreme would be further away from that center. If this was a +2, more extreme would be there. So I'm going to do norm CDF, -99, -2.03, 0, 1. This answer 02108, but then I have to multiply that by 2 because it's a 2 tail, and that's how the calculator gets this. So that's my p-value. Now we have to conclude it. So since my p-value is greater than alpha was 0.01 right up here at that significance level, we fail to reject HO. So if I'm not rejecting HO, that really just means I'm kind of keeping it. So I don't have any evidence to conclude that they're not randomly guessing. So it looks like they are randomly guessing. So we have no evidence to support the ha. P not equal to 0.50. That, so the ha in my mind would be they have magical powers, because if they're either guessing or they have magical powers, and if I didn't reject the ho, that means that they're guessing. So they appear to just be randomly guessing. If you had to do a confidence interval with this question, see, it said alpha is 0.01, so that means my confidence level would be a 99. And the formula for a confidence interval is p hat plus or minus z star p hat q hat over n. Because remember, in confidence intervals, I actually don't know what the p and the q are, even though I do know it here, but so that's 0.44, because that's p hat plus or minus inverse norm. So 0.99, so that means 0.005, 0.005, 0.1, and then 0.44 times 0.56 over 280. You could do, well, actually, let's get that value. That's negative 2.57. Actually, we don't really care about the sign of it because it's the plus or minus. But in the calc, stat test, one prop, the interval, because I'm doing a confidence interval. Now all the data's in there, except you should change this to 99 and hit calculate. So this is the answer, 0.36, 0.52. So I'm 99% confident that their guessing percentage is falling within this range. So to me, using this interval, I can kind of say it appears as though that they're doing worse than guessing. Because if you were guessing, you'd be getting 50%. These idiots are getting between 36 and 52. I mean, they're useless. They're trying to actually do this is rooting it for them. So it appears as though they're guessing anywhere between 36 and 52. That's why in research it's always important to bring a p-value to the table, but also give a range of plausible values here. Oh, I'd have so much fun doing this question to the group of touch therapists. They would love me. They would absolutely love me. Actually, wait. So, since the hoe is in the interval, see, HO is 0.5. that's in here, barely. If P was 0.6, that's not in the interval. But since it's in the interval, we fail to reject HO. So we could answer this question using a confidence interval if I tell you to. So if it's in the interval, I keep it, I fail to reject it. All right, 23. In a study of 420, all right, that many Danish cell phone users, 135 developed cancer of the brain from this institute. Okay, so test a claim of a somewhat common belief that such cancers are affected by cell phone use. That is, test the claim that the cell phone users develop cancer of the brain or nervous system at a rate that's higher from the rate of that for people who do not use cell phones. All right, so we're going to use this significance level. Okay, so take a second and think about what the HO and the HA should be, because I'm going to go to my answer key so I can do these questions a little bit quicker. All right, anybody want to come up with the ho and the ha? Mariana? Ben? Matt? Mike? Dave? Anybody? Joe. Okay, what you get, Joe? All right, good. 1, 2, 3, 3, 4, 0, and the HA, P is not equal to 0.123, 3, 4, 0. Now this is a percent, so I moved it over 2 to get this value. It's really, really small. You don't want these to be percents. On the other one I had 0.5, not 50%. So they're either getting cancer the same or they're not getting cancer the same, all right? Because it said different. It didn't say they're getting cancer more often. I mean, maybe cell phones are protecting them against brain cancer. So the test stat, Z equals P hat minus P, PQ over N. Now the P hat is 135 over 420,095. 135 over 420,095. Okay, so P hat 135, 420,095 is getting us 0.123321. Minus P over, well, 0.123340 times 1 minus that over 420,095 square root the whole thing. All right, that's a pain to do by hand, so let's go right in the calculator. So stat, test, 1 prop C test. So that's the ho. Now ho we said was 0.123340. X, N, and this one is also not equal to. Calculate it. That's the z-score, pretty small. Negative 0.66. That's not that far away from 0. P-value, well, negative 0.66, so I got to norm CDF that, and then I got to double it because it's a two-tail. So 2 times norm CDF, negative 9, negative 0.6601. That, just copy it right from the calculator. 0.51, that's your p-value. So conclusion. Since P is greater than alpha, fail to reject HO. I don't have evidence to say the cancer rate differs. See? I'm failing to reject the hoe, so I'm keeping the hoe. So I don't have evidence to support what that person said or what that claim is. Now, if you have to test it using critical values, it's basically the critical value is the inverse norm part. So alpha is this, all right? Alpha is 0.005. This is a little weird. They usually don't do alphas this small, but so I got to cut that in half. 0.005, cut that in half, 0.0025. 0.0025. Inverse norm, 0.002501. That's going to give me that cutoff value. So my critical values are plus and minus 2.81. Does my test stat fall in the critical region? No, it doesn't, because if this is negative 2.81, this is 2.81, these are my critical regions, like we talked about earlier. Here's 0. Negative 0.66 is over here. So since z equals negative 0.66 does not fall in the critical regions, we fail to reject the HO, and it will have the same conclusion. So it looks like the cell phones aren't really doing anything to the Danish. Maybe they got something different going on over there. But if they did, I don't know, Americans, who knows? Hard to tell. Same thing here, all right? So if you see a printout like this, you actually want this, it's a lot easier, but there's a problem in the chapter. It's in the county clerk in Essex County, New Jersey. Anybody ever been there? Anybody? Okay, good. Dylan, nice. Select candidates for positions on election ballots. Democrats were selected first in 40 to 41 ballots because he was supposed to use a method. Blah, 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 blah. Use a 0.05 significance level to test a claim the methods favored the Democrats. So that's why it's got 50-50, but favoring the Democrats. That's a greater than. So this right here, this is your p-hat, sample proportion. The standard error is p-hat, q-hat over n. That's your test stat. And that's your p-value. Less than 0.0001. It's smaller than that value. So since p-value less than alpha's 0.05, the p-value is pretty much 0 plus, we reject HO. So I have evidence to support it's greater than 0.5. So we have evidence to support that it's greater than 0.5. So it's favoring the Democrats, or it appears to be favoring. Make sure you write that down. It appears to be favoring. We can't prove it's favoring because we haven't interviewed everybody or we don't have all the data, but I have enough evidence to say that it appears to be based on the p-value. So next time you want to call somebody out on something and they say you can't prove it, be like, well, based on the p-value I found of you, I have enough evidence to call you out. See how far that gets you. We'll do this on another video.